All right, so let's talk about absolute value functions. And let's see, I'm going to move myself up here. Let's make this full screen so that you can see it a little bit better. So first of all, let's talk about what absolute value is to begin with. So absolute value is actually the distance between any value and zero on a number line. Now, the thing about distance is that it has to be positive, right? We don't have negative feet or inches or anything like that. So it's always positive, absolute value. It's always positive. Okay. And so this right here is what the equation looks like. That symbol, the two straight bars right there, that is absolute value. Now, this function, this f of x equals the absolute value of x, this is actually the there we go. This is the parent function. Okay, so parent function right here. Now remember, a parent function is like the most basic of all the function families. So this is the most basic of our parent function, or of our absolute value function. So here's what I want you to do. I want you to go ahead and go to Desmos and type in, there we go. Type in the absolute value of x. I'm going to go ahead and I've already got it typed in there for time's sake. And then put a table in there. And notice on your notes that we have -3, -2, -1, 0, 1, 2, and 3. Okay, so go ahead and take this data right here that's in this table and transfer that over into your notes. Okay. So here we have our x values in this column. Here we have our y values in this column. And then here we have our ordered pairs. Okay. Then we can see that what the graph looks like. Let's go ahead and just sketch that onto our graph over here on our notes. Okay, now let's talk about some of these vocabulary words. Some of these vocabulary words probably look familiar to you or sound familiar to you because we have talked about most of them. In fact, really, we've talked about all of them. So looking at domain, remember domain is all of the possible x values. Notice here that we have an arrow on the left-hand side and an arrow on the right-hand side. That means that our domain is all real numbers. Okay. Notice here how we have this point, right? So at the very bottom of this graph, we have this wall, so to speak, remember. So we definitely have some kind of range. It's not all real numbers. But up here at the top, we have arrows. So that means that we have our range values are y are greater than or equal to 0 because it's going up. And that bottommost, that smallest value, the point at the very bottom is y equals 0. Okay. Now, this point right here, this kind of, you probably are noticing that it kind of looks like a parabola or quadratic function, and that's true. It also has a vertex, just like a parabola does. So that vertex is this point right here, and in this case, that is 0. Now, this vertex also happens to be a minimum, and it is at 0, 0. Or y equals 0. I apologize. The minimum is y equals 0. The vertex ordered pair is 0, 0. Okay. So that's all things that we have talked about before. That's all domain and range. You guys are old hats at that by now. And vertex and minimum maximum, we've talked about that in quadratic functions. Okay, so now let's talk about our x-intercepts and our y-intercepts. Now remember, x-intercepts is where the graph crosses the x-axis, and it only crosses or touches the x-axis in this one spot right here. So that means that our x-intercept, we only have one of them, and it's at x equals 0. Now our y-intercept right here is this one spot as well. Now it just happens to be the same as the vertex, but that won't always be the case. So be careful with that idea. But this y-intercept is 0, 0 as well. Okay. All right. So now let's talk about this line of symmetry or the axis of symmetry. So for an absolute value, it's always going to be a vertical line. Always, 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 no matter what. So, okay, so that axis of symmetry or line of symmetry, it is this line, that vertical line. And you can't really tell, but I put a dotted line there. It's the vertical line that goes right through that vertex. Now, vertical lines are always x equals, and then that x value is 0. So our axis of symmetry is x equals 0, and I labeled that right here. Now, the slope of the sides. Okay, so, and we say sides because they're not, that it's not a technical term, but it's each side, right? So if we look at the left-hand side, we're going down 1 over 1, down 1 over 1. So that slope right there is -1. Then on the right-hand side, we're going up 1 over 1, up 1 over 1, up 1 over 1. So the slope, we have one that is +1, which is the right-hand side, and one that is -1, which is the left-hand side. And finally, remember concavity. So concavity basically is just the fancy math way of saying whether it opens up or down. Okay, so in this case, this one opens up, so it is concave up. So the concavity is up. All right, so it's pretty simple. It's just a matter of identifying all of these pieces about this graph. We're gonna do more with it, but for right now, we really just want you to focus on identifying all of these pieces and being able to see what the graph is going to look like. All right. So here's the next example. So here's our next example. And what I want you to do is I want you to go ahead and go to Desmos and plug that in. All right. So you've plugged this in. You've looked at your table right here. And then go ahead and plot the points on your graph. And then you will see that it looks like this. Okay. Now, take just a second and think about, let me go ahead and add that in there, and just think about what you think all of the pieces are going to be. So look at the domain. We have arrows on both sides. What's that going to be? Well, that's going to be all real numbers. Then look at the range. We have this similar situation, but now the vertex is all the way up here at 4. And it's still opening up, so we still have a greater than or equal to. It's greater than or equal to 4. Our vertex is at the ordered pair 2, 4. Now, notice the y values. So I want to point out the y values of the vertex and the range are the same. That's important. Also notice that for the minimum and maximum, the y value is the same. Okay. Then look for your x-intercepts. There are none. This absolute value sits above the x-axis and it opens up. So it does not ever cross the x-axis. So we just put does not exist, D and E. Okay, y-intercept. Of course, y-intercept is that point right there where it crosses the y-axis, and that is at 0, 6. Now, the axis of symmetry. That's this line going through the vertex. It's a vertical line, so it's x equals. But notice what number that is. Let me actually change colors because that will help us see. So notice what number it is. So it's x equals 2, and then look at the vertex, the x value of the vertex. So those are connected. So your range and the y value of your vertex and the axis of symmetry and the x value of your vertex are always going to go together. Okay. All right, so looking at this next one, I want you to give this one a shot on your own. So go ahead and plug that into Desmos, hit pause, and then fill out the table. Make sure you're using a pencil so that if you make a mistake, you can erase it easily. If you have a question, just raise your hand and we will be right there to help you. All right, so once you plug that into Desmos, here's what you should get. So you should get, let me make that just a little, there we go. You'll plug that in to Desmos. Here are your y values, your ordered pairs. Then you graph it here. Now notice this one is concave down, but we still have a slope of positive and negative 1. That's what that symbol means right there, plus or minus 1. So the left-hand side is positive 1, the right-hand side is negative 1. Notice how in all of these examples, the left and the right have had the same slope, but they've had different signs, different directions. All right, so how did you do on this one? If you missed up some, that's totally okay. Check with your teacher, check with your classmates, and discuss what all of these pieces are and what you may have missed. Okay, now go ahead and plug this next one in. Again, same thing. I want you to fill everything out and try to answer the questions or describe the pieces that are on the bottom of this table. All right, so here is what you should get. Now you'll notice this one looks a little bit different than the other ones. This one looks a little skinnier, maybe like it's stretched out a little bit. And those lines, the sides of the absolute value, they're steeper, right? And so when you counted that slope, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, you got a positive and a negative 2. One side was positive 2, one side is negative 2. So that makes sense, right? Because if the slope is larger, then that means that your line is steeper. And so the same thing holds true here. Now notice that you do have your 2 x-intercepts right here. But also those patterns, if you'll notice in the last example and in this example, the patterns are the same. So we still have our vertex, our x value, and our axis of symmetry. Those numbers match. Then we have our range and our vertex. Those numbers match. Also, the minimum or the maximum. In this case, it's a maximum because that vertex is at the top. All right, so that is a quick and dirty version of all the attributes of an absolute value function.